All right, so we are going to have an introduction to inner class. I'll create a new project because I'd like to introduce you to that. So what's this inner class thing? Well, the inner class is just having a class inside of a class. I mean, there are a lot of different things that I would like to talk about. I'm not going to talk only about inner classes, but also about some anonymous classes, which is something I will see in a few. But the idea is we'd like to use a class and define it inside another class. So what would be the objective of me defining a class inside of another class? Sometimes the class that I'm defining inside another class is just needed only by that class, not by other classes in my program. So I don't want it to be separated from the class it uses it, and I would like to just make it inside that same class. Now just to have an example, I remember I've seen there was some, let me see if I can use the slides that I found somewhere. I mean the slides of the book. If I can, well, I think I put them here, then somewhere here in this references, courses, and yeah, I think this is chapter 13. Wait, this is chapter 13. So yeah, now I don't need this. Let's just close, not save. I think I clicked on to start it. Yes, just takes time. Okay, so in this chapter 13 we have these interfaces, a lot of talk, and I strongly advise you to have a look at this because it gives some other examples of interfaces. Now I'm not using these slides a lot, not because whatever it's inside of them is not good. Maybe the slides design is kind of a bit cramped. We have a lot of information in the slides which are not meant to be like that. That's why I'm not using them much. I'll just go directly to the practical part so you can see on NetBeans how things are going, and that's what I'm trying to do. So I'll give you some practical explanation of the theory. However, you can find, after seeing this, you have an idea about what these interfaces are, or whatever the topic that we're discussing in the class are. You should have a look at the slides, because the slides are going to be containing some kind of more examples, more type of interfaces that you can have, something different from what we see in the class, so you can have more exposure to the topic. And I strongly advise you to do so. All right, so you have a lot of different things. You can have these different interfaces, you have examples of where they are used, and sometimes they talk about things that we didn't, or maybe I just mentioned. Remember when I told you that is it possible that an interface extends another interface? Well, check this. You have an example here where you have an interface that is extending another interface. So what happens when an interface extends another interface? Well, basically, if I'm implementing this, I will have to implement all the methods in here and also the methods that are from the super interface. So that's what it is. But you have to just have a look at that. And there's this comparable interface, which is a very important one, especially we're going to use that later when we would like to compare between the two objects. By compare, we mean not equal. Compare, we mean which one comes first. This one is before that one, or something like that. If we'd like to order a student, or I have points, I have movable points, I'd like to order them. Which one comes first, which one comes second, third, and so on. How can I do that? I need to have some kind of a method that is going to be allowing me to compare that to. Well, this is what the comparable interface is all about. So it's kind of an interesting interface that we're going to investigate and play with, inshallah, in the future. But have a look at it. So I'm going to just jump to all these things to blah blah blah. There's a lot of different kind of examples of interfaces, etc. But I'm going to focus on the talk on the inner classes. And this is a simple use of inner class, and that's what I'm going to be talking about. So anyways, I'm just going to use this example to show you that. Now let's have a look. Now this example just have a class called bank account, and inside that I have something called money, and that money has dollars and cents. It's like reals and halalas for us. And then I have the constructor which gives you an amount in text. Why is it in text? Well, because they do something. They're just looking for, like, to check it out. You remember that we did something just with the number to string, when we took a number as a double and then we took just the parts without the decimal values, and then that's what they do, but they do it with the string. Okay, so you just initialize it with this, so it just tries to take them with substring, because substring we have, if you remember substring, we can just count where we'd like to look at, and then we check this whatever we want. So this is an example, and then it just displays get the amount. It gives you the dollars dot the cents, or the dollars dot 0.0 and then the cents, whatever. This is just to show you 0.90 whatever. And then these are all, this add in, it adds another amount, which is another money. So there's some methods inside of it, but I think what I'm going to do, I'm just going to make it a very simple exercise. I think I was initially I wanted to use this, but there's a lot of different things going on here. I don't want to be I don't want them to be distraction. But later on, this class money is used as a type inside the class balance. You see, the class bank account, sorry. So the bank account starts here, but inside that there is a private class money that is going to be only available until this is the definition of the class, and then this is the definition of the bank account. And in the bank account we're using this balance, which is the money. The money is the inner class. So this is what I'm going to do. I'm going to do some similar example when I'm going to have, like, this is my main, so I'm going to create a new class. This is my, I'm going to call it outer class, and inside that outer class I'm going to make a private inner class. There is no inner class, I'm just going to name it like inner class. That's the name of inner class. So inside this inner class I'm going just to have, let's say, private, something similar to this. I mean, some private int value 1 and another private double value 2. I meant private. Now I'm just going to, this inner class is like a class. It can have all the constructors, the two strings, whatever you would like it to be, and I'm going just to add the constructor here that initializes them too. And you can see I'm just going to get the getters and setters if I want to, yeah, for both of them. And then what else can I do? A toString. I'm going to have a toString that is going just to display the inner class with the values and etc. So I can add whatever I would like to add inside that class. Now this is going to become like a type. Again, this has to be somewhere in the class. It doesn't have to be in the top or the bottom. It just has to be inside the class. The most important thing, it should be inside this, to be in outer class. Sorry, in inner class, because it's a class inside of inner class. Now I made it private because I just want it to be used by this class. But if I would like to be used by others, I can just use another access modifier. I can make it public if I want, so someone can also use it from outside of this class. But generally, it's very rare. I mean, you have a special case where you're going to use an inner class used from outside, because generally when you design an inner class, you want it just to be used by this one. If it was meant to be used by others, you just put it as a class as we used to do it. But this is meant to be used inside of this class, so that's why, and only by this one is going to be using it, so that's why you put it inside. Yes?
If I don't want anyone else to use the same class, what if I make the methods and variables private inside the outer class.
But you're inside the inner class. You're talking about this one, so you made this one private. But just putting this class private now, they cannot, outside of this class, they cannot have access to it.
Yes, but why make an inner class if I can make everything here private inside the outer class?
It's just about the same organization thing. Now, let me just tell you. Imagine now, I have some kind of methods that is going to be like, let me do this. Private int, maybe make it double. Add. That is going just to add the values of return value 1 plus value 2. So I'm doing something that is going to be a method inside here that is going to be used to work with whatever is inside here. Now imagine what I'm going to do here in the outer class. I'm going to create in a class like v1, which is variable 1 and variable 2 and variable 3. So I have 3 variables of this class. Now every time I'm going to initialize this this one, I need to initialize all the 3 variables. Now each one of these is an inner class, which means each one of them has 2 values. So I'm just would like to have like int I1, because it's an int 1, and then int 2, int 3, and then double d1, double d2, and double d3. Now this one, I'm just going to define a new with I1 and d1. So I'm going to create a new instance with all these 3 to be the second with the second, the third with the third, just to make it. So what I did, now if you'd like to define this outer class, you need to initialize with 6 numbers, 3 double, 3 ints, and each one double, 1 int is going to each one of this inner class. So if now you don't want to use the inner class and you'd like to call this add, it's going to be a lot of values that are going to be in the same place for you. So the main thing here, that why we do this, is just like it's a supporting class that is going to help me do the job of this outer class. So what kind of job is this? Well, it's not really something that is really fancy here, but I can, for example, show you that I would like to have this public void display, and in this display, what I'd like to do, I'm just going to display the result of v1 dot add plus v2 dot add plus v3 dot add. Now I'm doing what? I'm adding all these numbers together and display them on the screen with this display add. Let's see. So it's going to be easier for me to do this in an organization that is going to be an inner class that I'm going to be able to call it there. Now notice what I'm doing. This v1 is, I'm going to make things simple because I realize that it's going to become a little bit too many variables to follow up. I'm going to make it simple with just this. Now I have only one variable. I have this inner class, and I'm having all this variable. This v1 is inner class. I'm just going to remove this. What is its data type? Is v1 is an inner class, which is this class here, which means this v1 has everything that this inner class has. And notice now the inner class, I can see it here inside like this. So you have the outer class, whatever it's inside of it, I have only display add with the outer class constructor, and then this v1, which is a package. Let me make it private. And then here I'm going to use also the inner class with all what it has. Now notice one thing. This here is private, and this is calling a private method from v1. Now this is the inner class, and I'm calling a private method of an inner class from the outer class, which is possible. Remember the definition of a private method? Private method means we can only use it inside its class it's declared in. Now with the inner class we have some kind of interesting behavior, which allows me to, all of these that are private inside this inner class are also available inside the outer class, which means if I'd like to do something else, I can do like v1 dot, and I can see the value that is private, the value 1, I can also display it. And I can also display whatever it's private there. So the main advantage, first of all, is to organize these things, having like a class inside of another class, because this class is used by the other one. Now this inner class is being used by the outer class, then I'm going to define it inside of it, because first of all it's not meant to be used by others, it's only meant to be used by this class. And that's why I want to put it inside. And the second thing, it will allow me to have access to all private members from each other, because even this v1 is also accessible. Now what is v1? This is v1, which is a private variable in the outer class. So when you have inner classes, it's like in the same class. All the privates are accessible from everywhere. The outer class, the private instance methods, instance variables and methods in the outer class are available inside the inner class. Same thing, the ones inside private are also available outside of that class, in the outer class. So you can have some kind of accessibility which is going to be needed for what we're going to be doing next when we're going to be designing graphical user interfaces. Why? Because when I'm going to be designing graphical user interfaces, when I click on a button, the code of that button is going to be needed to be inside of a method. Now that method should be in the class. Now that class is going to be an inner class, or something else that we're going to say like an anonymous class, but anyways. So because this code is only needed by this graphical user interface that is going to be needed in that class. So that's why this is also something that is going to be a good feature that we would like to have. Inner classes are going to allow us to have access to private members, and also make sure that only the outer class is going to be using this code of the inner class, because we don't want it to be used by anyone. Now why I don't want it to be used by anyone, because if I click on the button, another window doesn't need to use that button, so it doesn't need to see this code. So this code, I don't want it to be available for everyone. This code should be used only by this window, this class that is going to be designing this window. So that's why I'm going to put it inside that window. That's why the idea of this inner class and outer class. So just anyways, I don't want to go too deep in that, because we're not going to be using a lot of these things for now. But just as an introduction, the main idea is, and when I have a class inside of another class, the main goal, the first goal, is the inner class is going to add in some support to the outer class. It helps the outer class do its job. And then the advantage also comes from the fact that I can, from the outer class, access all private members in the inner class, and vice versa. From the inner class, I can access all private members of the outer class, because basically it's like one class, but they're just organized differently. Now there's some kind of details that you can find also in the slides about how, if I would like to have a static inner class, but I'm not going to be, or public inner class, if I'd like to access a public inner class from outside, what should I do? Well, that's something interesting, but we're not going to be using it for now, and I'm not going to be talking about it for now. Just now, what I would like you to know is that there is something called a class inside of a class, and it's called inner class. And when this is happening, the main thing that I can do is that all the private members in the inner class are available in the outer class, and all the private members of the outer class are also available in the inner class. By members, I mean variables and methods. Now there's another thing that also is very convenient that we're going to use. This is something that is called anonymous classes. An anonymous class is a very interesting class, which is, I don't know, let's have a look at this. Do I see number carry? Okay, let's see. No, let me just do another example. I'm going to use another example. You have an example in the book, but I'd like to use another example. Now, let's save. This is the inner class, whatever. Notice this, movable. Movable is an interface, right? We've just seen it a few minutes ago. You remember movable, because it's an interface, I can declare a variable from it, no problems. But I cannot initialize it. I cannot do create an object from movable. I cannot do something like this. Why? Because it's an interface. It's not even an abstract class. It's an interface. It's something that, like an extreme case of an abstract class. Abstract classes, we cannot instantiate them. Now, an interface, obviously, we cannot instantiate them. But what if I do something like this? Okay, I'm just going to use the help of NetBeans because there's so many methods in that movable. I don't want to type them myself. Check this. Now, just to make this something that makes sense, I am moving up. I am moving down. I'm putting some code in those. I am moving left. I am moving right. And all I need to do is to do this. Now check this. M now is an object of this new movable. But is this the movable, the interface? No, it's an implementation of the interface. But what's the name of that class that implements the interface? Well, it doesn't have a name. But it implements all the abstract methods. So it is fine, which means M dot is going to be having this move down, move up, whatever it is. It's implementing all the abstract methods. And this becomes, what is this class? It's an anonymous class. It's a class that doesn't have a name, but it's a class that implements the movable interface because I put the code of all the abstract methods. I defined all the abstract methods. And it's only working on those classes that have either interfaces or abstract methods, basically. So it can have an abstract class or an interface. I can instantiate, I can create an abstract anonymous, I can instantiate an object from an abstract class or an interface by creating an anonymous class that implements all the abstract methods that are needed to be implemented. And it makes it kind of complex if you have a lot of methods to implement. But it's possible. And this is called anonymous class. Yes. Can I put the class in the main? What do you mean? Can you raise your voice? Can I put this in the class? Which class? When you say this, what do you mean? The whole thing? Yeah. I can put this whole thing in one of the circles, for example. Where, for example, I can do something like this. It doesn't have to be in the main. So I say, for example, this is a movable m. Now this m is like a variable inside this movable circle. And this m, what is its data type? Well, it's a subclass of movable, but it's a new class that is implementing, it's an anonymous new class that implements all the abstract methods. So that's what these abstract anonymous classes are. They are just like an implementation of a method. I don't need to give it a name because I'm not using this much. I'm also using it for a specific task, and that's why it's just something that is possible. Now, it doesn't make a lot of sense, but it will very soon make a lot of sense. What I'm going to start now, very few minutes after this, designing a graphical user interface and putting the code when I click on a button to do something. I need to do that in this. Either I'm going to use this anonymous class like this, or I will just use an inner class. And that's what we're going to do next. Yes?
In the first we can't create an object, right?
No.
What does to use
Well, this is an interface, right?
like a special, right?
Anonymous class. Yeah. But the most important part is that I need to implement all the abstract methods, and that's what I'm doing. If I implement only some, it won't work. You see, it will tell me, no, sorry, you cannot do that because some of them are missing. But what if I don't want to implement all of them? Well, you cannot make this abstract because you want to create an object here.
This is abstract because it's movable, it's like that.
No, but now I'm defining. I'm putting the code of each one of these abstract methods. So this is, notice I'm opening a brace here. This is I'm creating a new movable, and then there's a brace here that is open and closes here. It's like I'm defining a class in this object. But what's the name of that class? Well, I don't know. It's just an anonymous class. It doesn't have a name. It's just a class that is going to be from movable. But what is the name of that class? I don't know. It's anonymous. But the most important thing is that it implements movable, because all the abstract methods are being implemented. Did I answer your question? Yes. Get class? That's a good point. If I use get class, what should I see? Let me just do this. So what do you expect to see here? Remember the get class? We were talking about get class instance of, what's the difference? So get class gives me the data type of this object, the class it belongs to. Now, the class it belongs to is some kind of anonymous class. So what's the name of that class? Now, I've never tried that. And this is it's some kind of a weird name, but it is not movable. The data type is not movable. It's inheriting from movable, but it is not movable. Now, what I can do as a follow-up of this good question, what if I use instance of? Is this an instance of movable? So remember, this instance of is going to just give me true or false. So I'm going to say, is M an instance of movable? Well, it should be true, because movable. Now this is the M is an instance of an anonymous class that inherits or implements all the movable. So basically, it's movable. I don't know the name of its class, but it definitively inherits from, it implements movable. So if I run this thing, I'm expecting it to be true. But the name of the class, it's an It's a given name that is going to be randomly given by the compiler. That's why it says like week 3 exercise 1 and then $1. I don't know if this this doesn't qualify to be a valid name of a class, right? Because this is not a correct name of a class. Because remember, the names of a class or identifiers in general, variables, they have to not start with a number, not be keywords, and then they should have only letters, numbers, and underscore. This dollar here doesn't make it a correct name of a class, which tells me that this is not the name of the class. It's just like some kind of tells us, the compiler tells us this is an anonymous class and this is maybe the first anonymous class. If you define another one, it might have another one which is the same thing here and this number 2, $2 and $3. The more number of anonymous classes that you define, the more the number is going to increase. So it keeps track of those, but it doesn't give them a name because they don't have a name. But thanks for the question. Is that okay? So anyways, what I'd like you to know for now is that an anonymous class is just a class that can be defined at instantiation, but it implements all the abstract methods either from an interface or an abstract class. If I can have an abstract class and then I can new whatever from that abstract class and I'll be able to do so. I just would like to show this to you because I'd like to remember when we saw an abstract class. Yes?
So the definition of an anonymous class is implementation of an abstract class or interface with their methods? Or
Is what? An implementation of?
an abstract class or an interface?
An implementation of an abstract class or an interface.
Or should I say instantiation?
Well, it's an instance of I don't know if I'm trying to remember. I'm trying to find actually a question, the file that I was working on. Anyways, you said that your sentence that you want me to check is, can we say that an anonymous class is
Implementation of
an implementation,
an abstract class or an interface?
an abstract class or interface? Yes.
So that's correct. So
Yes, and an anonymous class is
instantiation.
an instantiation.
Yes. It's better.
Well, it's used in it's in implementation. It's better because in instantiation, a class is not an instantiation, but it is used when you instantiate from an interface or an abstract class. It's not an instantiation itself because an instantiation is meant to when you create an object. That's what instantiation means. But an anonymous class is a class, so it's a type. But it's a type. Now, when we do this, for example, I create a type from movable, which is I'm doing this. I'm creating an anonymous class, and then I'm doing an upcasting immediately, because I'm not putting this into the name of the anonymous class. I don't know what's its name, but I'm putting it inside of a movable, which is the super class of that class, anonymous class. So I'm doing an upcasting. I'm instantiating a new object from an anonymous class, from a class that I don't know the name, and then I'm putting it inside of a movable, which is then I'm doing an upcasting inside the movable. All right? A lot of fun, right? I know, but it will make more sense once we go into the graphical user interface programming, which is going to be in a few.